Questions 21 to 25 of the 1998 Grade 10 Cayley Math Contest is what I will discuss in this video. When Betty substitutes x equal to 1 into the expression ax cubed minus 2x plus c, its value is negative 5. When she substitutes x equals 4, the expression has a value of 52. One value of x that makes the expression equal to 0 is. Alright, so let's first write out our main expression. And first thing, of course, we'll substitute x equal to 1, which is right there. So if x is 1, we have this, and this equals a minus 2 plus c. And they're saying that that is equal to negative 5. So that's our first equation. The next one is when x is equal to negative 4, or positive 4, sorry. So we've got 4 cubed minus 2 times 4 plus c. And that becomes 64a minus 8 plus c is equal to 52. All right, so looks like these two equations, if we work with these two, we'll be able to solve for a. So if this is 1 and this is 2, I will do 2 minus 1. So I will get 64a minus 8 plus c minus a minus 2 plus c, and on the other side we'll get 52 minus 5. All right, so this becomes 64a minus 8 plus c minus a plus 2 minus c is equal to 57. So 64 minus a looks like 63a. The c's cancel, and then we have minus 8 plus 2, which is minus 6, is equal to 57. So 63a, if you add 6 to both sides, you will get 63, and therefore a is equal to 1. So that's definitely helpful. And we can solve for c. We can put it back into that equation. And we have 1 minus 2 plus c is equal to negative 5. So c is negative 5 minus 1 plus 2, and therefore c is equal to negative 4. So now our main expression is x cubed minus 2x minus 4. Because we know that a is 1 and c is minus 4. Now they are saying in the question, one value of x that makes the expression equal to 0 is. So we want to make this expression equal to 0. So we can definitely do that, and let's see what we get. If we set it equal to 0, this is unfortunately not a quadratic equation because you've got a power of 3, so we can't use the quadratic formula, but we can probably factor and use inspection. So if we do that, factor out an x, we get x squared minus 2. And if you look at this and fiddle around with the numbers, you should be able to get a value for x. If x equals 1, we're going to have 1 and then 1 minus 2, which is negative 1, and that's negative 1. That doesn't work. If x equals 2, we'll have 2. 2 squared is 4, 4 minus 2, and this is 2 times 2, which is indeed 4. Great. So x is 2. That's one solution of this question. And that would be choice A. A wheel of radius 8 rolls along the diameter of a semicircle of radius 25 until it bumps into the semicircle. What is the length of the portion of the diameter that cannot be touched by the wheel? All right, so I'm going to draw this out a little bit bigger. All right, so first let's try to understand what the question is asking us, and then we can approach how to solve it. So this is a wheel here, a small wheel, and it's got a radius of 8. So from here to here is 8. And it's going in that direction. So initially it touches the big semicircle. So this is the diameter. And it touches the big semicircle at that point right there. And then as it travels, it will travel, of course, along this line. And eventually it gets to here. And that's where it bumps in here. Okay? So it will touch the semicircle, the wheel, along this area. It will not touch here, where I'm drawing it in red, and here. So that is what the question is asking. What is the length of the portion of the diameter of the big semicircle that cannot be touched by the wheel? So therefore we'll call that red region X. And we'll call the blue region, we can call it Y. All right, so that's what the question is asking us, and we can, of course, move forward with that. Now I'm going to draw a few important necessities in this diagram. The first is, of course, we need a radius, so that's the radius, and I'm also going to draw it to the point where it touches the large semicircle. And then the center of the large semicircle, I'm going to draw a line from there to the center of the small circle. Now we can label this. So this part here is the radius. So we were told that it's 8 up here. So that's 8. And then this part here is also the radius. So that is 8. And anything else that we know? Or do we have to now just introduce variables? Oh, we know that the radius of the large one is 25. So that means from here to here is 25. So that means from here to here is 25 minus x. Okay? So just going to draw a big circle in there to note that that's the center of that large semicircle. All right? And similarly, this is the radius of the large semicircle. But this part is 8, so therefore this part will be 25 minus 8. All right? And this is, of course, a right angle because that was a perpendicular that I drew. So this triangle right here is going to give us what we need using Pythagoras. So we've got 8 squared plus 25 minus x squared is equal to 25 minus 8 squared, like that. So let's figure this whole thing out. We've got 25 minus x squared. 25 minus 8 on this side is 17 squared. And then bring this over to the other side, 8 squared. So 25 minus x squared. 17 squared, I believe, is 289. 8 squared, of course, is 64. So 289 minus 64 is 225. 25 minus x squared. Take the root of both sides, and that would give you 15 over here, and 25 minus x on the left side, and therefore x is equal to 10. So x is 10 over here, x is 10 over here. So the total length of the portion of the diameter that cannot be touched by the wheel is x and x. So 2x, which is equal to 20. So the answer is E. There are 4 unequal positive integers a, b, c, and n such that n is equal to 5a plus 3b plus 5c. It is also true that n equals 4a plus 5b plus 4c, and n is between 131 and 150. What is the value of a plus b plus c? All right. First, let's write down the information that they give us and see how we then need to proceed. Most likely a lot of number manipulation. And they've given us that n is between 150 and 131. All right? Find a plus b plus c. All right. So I'll call this 1 and I'll call this equation 2. So I'm going to try to see if I can eliminate anything to solve for something. And I believe if I do 2 times 1 minus, or rather 4 times 1 minus 5 times 2, I think that's going to help me. So on the left side, I'll have 4n minus 5n. And on the right side, I'll have 4 times 5a plus 3b plus 5c minus 5 times 4a plus 5b plus 4c, like that. So this gives you minus n, and this gives me 20a plus 12b plus 20c minus 20a minus 25b minus 20c. And I did that for a purpose because now the a's cancel and the c's cancel. So I've left with minus 13b is minus n, or n is equal to 13b, and b, therefore, is equal to n over 13. All right? So that's the first part of our manipulation of these equations. Now, where do we go from here? Looking at this carefully, we want to find a plus b plus c. And if I can somehow get that, or at least a multiple of that, I can then use this equality, this comparison. And is there any way, when I looked at these two, the first thing I noticed that if I add them, 1 plus 2, it's not a perfect match. It's not like all the a's, b's, and c's have the same coefficient. If they did, that would make it very helpful. But we do come close. When you add them, you get 2n on the left side, and then on the right side you get 9a plus I believe 8b and 9c. So we've come close, but unfortunately no cigar. But we can always manipulate, right? So what we can do, and this is perfectly allowed, is we can say 9a plus 9b minus b plus 9c. You see what I did there? I just broke up 8 into 9 minus 1. Haven't changed anything. And then this becomes 9a plus 9b plus 9c minus b is 2n. And this one we can work with. Now what we need to bring down is this statement, which is very important, that n is between 131 and 150. So n is between 131 and 150. So Therefore, 2n, which is what we have, is going to be between 262 and 300. Correct? You just multiplied by 2. Now, this here is equal to 2n. So that means this is between 262 and 300. So I'll write that out. 9a plus 9b plus 9c minus b is less than 300. Okay? And the good news is that we know that we can factor out the 9. A plus b plus c. Because we're very much interested in a plus b plus c. That's what we're trying to find. And then we've got this lone b out here. But b we already figured out in terms of n. So I'm going to put that in there. N over 13 is less than 300 is greater than 262. All right. Now what we have to do is bring the n over 13 part over to both sides. So it becomes 300 plus n over 13 and 262 plus n over 13, like that. And n over 13 is what? Well, n is between 131 and 150. So 262 plus n, the lower limit is 131. And on this side, the upper limit of n is 150. All right? And of course we have 9a plus b plus c, like that. So then you do the math here, and this comes out to about 272, and this comes out to about 311 and something, 0.5, I think, 0.5. And then this is still 9a plus b plus c. Now divide by 9, and you'll get 30.2 a plus b plus c, and this one will be 34.6. So a plus b plus c is between these numbers. It's between 30.2 and 34.6. Now let's look at the answer choices. Is there anything between 30.2 and 34.6? The only one is choice D, so that's the correct answer. 3 rugs have a combined area of 200. By overlapping the rugs to cover a floor of 140 meters, the area which is covered by exactly 2 layers of the rug is 24. What area of the floor is covered by 3 layers of the rug? Okay, let's draw a diagram. Okay, I've drawn 3 rugs. I've got an orange rug, and I've got a green rug, and I've got a blue rug to represent the 3 rugs. All right? And let's see here. This part I'm going to call A, and you'll notice that that part of the floor is only covered by 1 rug, namely the orange rug, so I'll put 1 in brackets. This part here I'll call B. That part of the floor is covered by 2 rugs, the orange and the green. They're overlapping, so I put 2 in the brackets there. This part of the rug, or this part of the floor, I'll call C, and that part is covered by 3 rugs. It's covered by orange, green, and blue. So put 3 in the brackets there. And D is covered by 2 rugs, and E, that part of the floor, is covered by just 1. All right? Now, let's work with the information in the question stem. So the 3 rugs have a combined area of 200. So the orange rug if we look at our diagram, essentially is A plus B plus C, right? The green rug in our diagram is B plus C plus D. And the blue rug in our diagram is C plus D plus E. All right? So the combined area of the rugs is 200. So if we add all of these, it would equal 200. So let's add them. We get A plus 2B plus 3C plus 2D plus E. That's the first piece of information. The next is by overlapping the rugs to cover a floor of 140. So they're saying that when you make an overlapping of that nature, that total area is 140. So that basically means that A plus B plus C plus D plus E is 140. And the final piece of information to tell you is that the area which is covered by exactly 2 layers is 24. So in our diagram here, what areas are covered by 2? Well, I told you B and D. So B plus D is 24. And I think that is enough information to solve the question. So let's go and start with that one right there. Let's write it out. A plus B plus C plus D plus E. And we have a B left over, a D left over, and 2 C's left over. And that equals 200. The reason I broke it up like that is because we know what A plus B plus C plus D plus E is. It's 140. So that can go there, 140. We also know what B plus D is. It's 24. So therefore, we have 140 plus 24 plus 2C is equal to 200. So 2C is equal to 200 minus 140 minus 24. 2C is equal to 36, and therefore C is equal to 18. And that is what the question was asking us. What area of the floor is covered by 3 layers of the rug? 3 layers of the rug represented by C is 18. So the answer to number 24 is B. One way to pack a 100 by 100 square with 10,000 circles is to put them in 100 rows with 100 circles in each row. If the circles are repacked so that the centers of any 3 tangent circles form an equilateral triangle, what is the maximum number of additional circles that can be packed? All right, so let's try to understand this question first before we tackle it. So you've got this giant square, okay? Big square, and it's 100 by 100. So it's 100 by 100. 100 centimeters, 100 meters, we don't know, but it's 100 by 100. And they are packing it with 10,000 circles, all right? And each circle has a diameter of one unit. So you've got circle, 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 like that, okay? And this goes on until you get to the end, okay? All these circles are the same in terms of size. They all have a diameter of 1. And then similarly, you just keep going down like that. And they're in 100 rows. So this is 1 row, 2 row. There's going to be 100 rows. And each row will have 100 circles. So because there's 100 rows and each row has 100 circles, you have a total of 10,000 circles. All right? So that's the first part of the question. Now they're saying they're going to repack these so that the centers of any 3 tangent circles form an equilateral triangle. Okay, so that means that this scenario is going to happen. Instead of you drawing circles like this, which are essentially right on top of each other, you're going to draw circles of this nature. One circle, two circle, and then the third one will be like this, so that they're tangent. And their centers will form an equilateral triangle like that. Okay? So let's draw it like this and see what we get. Okay, so this is how they're repackaging it. Alright? So this just keeps on going. I'm obviously not going to draw all the circles. So this is the first row, this is the second row, third row, and so on. Alright? Now the first row horizontally is exactly the same. Nothing has happened. So there's still going to be 100 circles in that first row. The third row, same thing. Horizontally, nothing has changed. It's going to have 100 circles. But the second row, the key point is to understand how many circles are there in that second row when you've moved things over like that. And the answer is 99, because you'll have enough space for only 99, all right? Because you've essentially shifted things so you can't put a full 100. And that should be intuitive, because see, you've got 3 circles on the top here, 1, 2, 3, and you have one less number on the second row, right? So if there was 100 circles on the top row, there'd be one less on the bottom row. All right? So now what we have to do is draw some radius, radii, and figure out the height. So first thing I have to do is draw a line here like that, and I have to do that so I can figure out the height from here to here, from here to there. This height is going to be very critical to our question. I'll label it H, because that is the height of a double row. Height of a double row. And if we can figure that H out, we will be able to move forward with this question. So now let's start labeling some radius, or radii rather. Here's the first one. Here's another radius that goes to the tangent. Here's another one, goes all the way up to meet that one. And we're going to draw this one here to the center, this one here to the center, and there. And then this one here like that. And I think we'll draw a couple more that we need. And that should be sufficient. All right, so the question tells us that the centers of any 3 tangent circles form an equilateral triangle. So this circle, for example, and this circle are tangent, and their centers form indeed an equilateral triangle. All right, now let's start labeling the values. From here to here is the radius of the circle, and they told us that the diameter is 1, so therefore the radius is 1/2. From here to here, similarly, it's 1/2, and the distance from here to here is also 1/2, so I'll squeeze that in there. And the distance from here to here is also 1/2, because that's the radius. And the distance from here to here is one full radius because you have the radius here and then you have another radius. So that would be equal to 1. This is 1. All right? So now I'm going to take this triangle and do the Pythagorean theorem on it to figure out the length of this, which I will call small h. All right? So I'll just draw that triangle over on the side here. So this is a half, this is small h, this is 1. So h squared plus 1/2 squared is equal to 1 squared. So h squared is 1 minus 1/4. H is equal to 3 over 4, h squared, and therefore h is equal to root 3 over 2. All right? So that's going to help us. Now, in order to figure out this big H over here, we just need to figure out this part right here. That's the last piece of the puzzle. Well, we already know that from here to here is this one, root 3 over 2. So therefore, from here to here would be root 3 over 2 minus this part, which is a half. All right? So now our h is equal to this h right here, a half plus the small h, which is root 3 over 2, plus this little guy right here, which we calculated as root 3 over 2 minus a half. So that looks like the halves cancel, and that just becomes root 3. All right? So that is very important to proceed with the question. Now, do you remember what is the full height of this square? It's 100. The square was 100 by 100. 100 on that side and 100 on the other side. Well, it's a square, so of course it will have both sides the same. So this h has to fit into that 100. How many times? Well, you divide 100 by root 3 to see how many times can you fit this double row. All right? And if you do that, you'll get 57.7 approximately. So that means you can fit 57 double rows into this square, because each double row is root 3. Now, if you fit 57 double rows, is there any space for any more? Well, let's figure this out. 57, each double row is root 3 in height, and if you do the math, you'll get 98.7. Now, the full length of the side of the square is 100. Do we have any more space for another row? And the answer is yes. We can put in a single row. See, this is a single row. The single row has a height of 1 because it's a circle with a diameter of 1. So we can put one single row, and that has a length of 1. So you would have 98.7 plus 1, which is 99.7. And that would fit into that square that has a total height of 100. So now all we have to do is figure out how many circles. So we have 57 double rows, and we have one single row. Each double row contains how many circles? If you remember, row 1 has 100, row 2 has 99. So a double row would have 100 plus 99, 199. So each double row has 199 circles, and a single row has 100. So to figure out the total number of circles, it would be 57 times 199 plus 1 times 100. And this is equal to 11,343 plus 100, which is 11,443. So the question is asking, how many additional circles could we add by doing it this way, by repackaging it in this way? And initially there was 10,000. So we repackaged it and managed to get 11,443. So how many additional did we get? Well, you subtract the two and you get 1443. So that's how many additional circles we can pack with this method. And the answer is D. And one final addendum I want to add to this question is that when you have n rows, the height is going to be equal to the following. And this is a formula that you can figure out directly from the question, based entirely on the math that I did. Okay, this is the height. And we want this to be less than or equal to 100, which is the height of the square. So we can use this also to solve for n. Now if you do the math here, you'll get n minus 1, root 3 over 2, plus 1 is less than or equal to 100. So n minus 1, root 3 over 2 is less than 99. N minus 1 is less than 99 times 2 over root 3. And if you do the math here, this becomes 114.31, n minus 1. And therefore n is less than or equal to 115.31. N represents the number of rows, so the maximum n can be is about 115 rows. And that's exactly what we had. We had 57 double rows, and we had one single row. So 57 double rows is 57 times 2. One single row is 1. 57 times 2 is 114 plus 1, which is 115, which is exactly what this formula gives. And this formula you can get entirely from the mathematics in the question and in the diagram that I wrote.